right? You are enjoying yourself so far?
No.
No, why? Why? You can work, right? But you see, enjoy yourself, you can with food, no? Everyone got food to eat.
Yeah, because this is like the only time I can eat. Yeah, exactly.
What? This is the only time you can eat? How is that possible?
Because
This is the only time we should eat in peace.
Yeah, we take money from our PE bank.
Oh, so you have you're authorized to withdraw cash.
Right. Wait, no, I'm not. Thank you.
Okay, right. So, how many more weeks to PSLE?
23,
How many?
24 more days.
Now it's already September. It's already
24
September.
more days.
You're
Okay.
doing a countdown.
Yeah, the PSLE is this
I
month.
did from Zoom.
Right? This month.
Oh,
Because
yeah.
Okay, so the PSLE is this month. Right? Now as you are enjoying your food, okay, let me just remind you again. Why do I allow you all to eat? Because you are P6 student, right? You're not P1, P2 anymore. That means, what does that
So it
mean?
shouldn't be.
No, what does that mean? That means you all don't drop potato chips on the floor. Look at Jonah's chair. Only P1, P2 students do that.
Yeah, I didn't do this. I didn't do this. No, really,
Alright, and then you all don't drop your drinks like all over the table. That's why we have plastic covering, right? For the boys sitting over there, right? They get plastic tables. Okay, right? So this is what I need you all to do. If I see any food crumbs,
Then you're gonna ban.
if I see any water spillage, that right, go
Really,
into my
No,
carpet.
then you're
How much on?
Now we saw him at the supermarket.
What supermarket, right? And any biscuit crumbs like all over the place, okay? I'm going to eat, I said eat, right? Because you are P6, mature, going to secondary school, teenage students, teenager already, right? So you all have the maturity to take care of your food and your drinks and your crumbs of stuff. Yes.
Thank you.
Okay, so we are now going to go through revision like what we did previously. We will go through, yeah, you can take, right? We will go through some topics first before we attend the paper, right? No, so last week we did the multiple choice paper. This week we're going to do an open-ended structured question. But as usual, I will go through the concepts and some subjects, information here which will be related to whatever you're going to do later, right? So the very first one in my list is this adaptation. So in adaptation, there are two types of adaptation. We have physical adaptation and behavioral adaptation. Okay, so what is the difference between physical and behavioral? Later on, there are a lot of things at the bottom which you need to classify according to whether is it physical. What? Structural, right? Physical is also structural. Structural adaptation and behavioral adaptation. Okay, so we're going to give it a try, see whether you know. Right, so the first one here, this one. So polar bears have thick fur to blend in. Is this structural or behavioral?
Structural.
Hey, what happened to your eye?
No, he fight with me.
Yeah. Huh? You fight with what? Polar bear? Huh? What happened?
I scratch.
You scratch, You scratch. Then, oh no. Okay, you must, hopefully you can open now,
PSLE oral over.
Yeah, so polar bears, I think, is this structural or behavioral?
Both.
Huh? Thick fur, no? Thick white fur. Structural or behavioral?
Structural.
Structural, okay, good. Okay, next one, the one on the right hand side. Chipmunks gather acorns throughout the summer months and store them for winter. Behavioral? Okay, so it doesn't mean that if it's classified here, it is behavioral, okay? Right, you have to shift, okay? I'm just going through them. So this is behavioral because there's no physical change, right? Okay, next one, over here. The birds migrate south for the winter to avoid cold weather. Is it structural or behavioral?
Behavioral.
Migrate, so they fly, okay? So this is behavior, it's not structure, right? Next one, horses have hoof feet to help them run for long distance. Hoof feet to help them run long distance. Yeah, structure, the hoof, okay, so it's structure. Next one. Okay, let me try to make it bigger because. Oops. Okay, ducks have web feet to swim more efficiently. Web feet. Is it behavioral structure? Yeah, structure. This is structure. Bears hibernate during winter. Hibernation during winter. Is it structure or behavior? Behavior. Okay. Now hawks have toes that are talons to help them catch prey. Structural. And the last one, wolves travel in packs to help them hunt. Packs means yeah.
Can I take a photo of this?
Oh yeah, sure, of course. Oh, there's still some more, right? But never mind. We don't need to go through all of them, okay? Later remind me to show you all the video, right? That you have taken. Okay, okay. So this is structural and behavioral. Okay. What's going on? Okay, so another example, frequently asked question is the peacock. So if the peacock were to do a dance, like do a peacock dance, is that structural or behavioral? Behavioral. Now why does the peacock do the dance? Like open up.
For mating.
Yeah, for mating. Okay, attract the mate. Okay, next. Okay, next, frequently asked animal. Okay, the camel. Now, you don't, sometimes for adaptation, oops, what's happening? Now, for adaptations, right, you don't just need to know whether is it structural or behavioral. You need to know exactly why certain things are, what's the purpose of certain structural adaptations. Okay, so for example, the camel, the hum. Okay, what's the purpose of hum? Store what? Fats. Okay, it does not store water. So a lot of people have the misconception that it stores water. It's no water. It doesn't store water here. Store fats, so that it can go for a long distance without eating. Okay, because it cannot buy food like you go NTUC buy.
You know money, what?
Yeah, no money, right? Okay, strong, sturdy legs, right? Leathery knee pads for kneeling because not praying, right? They kneel down, right? They don't just drop like this, you see, so they kneel down so that the people can climb to the top. What else do they have? Wet, twin-toed feet. Twin, that means very big feet. Each feet got two toes like that. Yeah, to prevent it from sinking into the sand. Prevent it from sinking into the sand because it's very big surface area. Big surface area. Okay.
So India for it.
Yeah. What else does it have? This one, leathery mouth. What's a leathery mouth? Why does it need leathery mouth? Because it will, chew thorny plants, cactus. It needs to chew cactus. So it needs very thick, leathery mouth. Okay, slit-like nostrils. Now our nostrils is like round. Theirs is not like big round nostrils. Star shape, no, it's slit-like. Okay, so it's very slit. This one slit-like. To prevent the sand from going in. Okay? Right, next. Okay, so there's also this particular question about eggs. Let me show this.
I've got a couple of eggs here. I've got a hen egg and a guillemot egg. And you'll notice they're both pointy at one end and round at the other. But in the case of the hen egg, there's not much in it. The pointy end is only slightly pointed.
Okay, the idea is this, right? Why are some eggs more pointy than the rest? How come eggs are not like round, like one sphere bowling ball shape? Why do they have to be pointy? like
So
pointed.
Again, the track between the ledges of rock.
Yeah. Okay. So we're gonna see why. Okay. In this video, he will do the demonstration. Why? Let me fast forward. Okay. So birds. There are some birds that live on the edges of the cliff, right? So the area where they lay their eggs, right, is very small. The area is very small. So if you have eggs that's round, it will roll off. But here he will demonstrate how come when you have pointy eggs, right, it will not roll off. So let's take a look.
And round the other doesn't roll along a straight path, it rolls around a curve. So the hen egg rolls around the curve as well, but it's not as pronounced. The bigger the difference between the pointy end and the round end, the tighter the curve roll around. So why would guillemots evolve to lay eggs that roll in tight circles? The answer is that they build their nests on narrow ledges on the sides of cliffs. So if a guillemot laid an egg that rolled in a straight line, and it was accidentally pushed out of the nest, then there's a good chance that it will roll off the ledge and into the sea. Hens don't have to worry about that sort of thing, but guillemots do. And this is a brilliant example of evolution at work. Through the natural variation of genes, some guillemots have pointier eggs than others, and the pointier eggs are less likely to fall into the sea. So genes from pointier eggs are passed on to the next generation. If you put a guillemot egg on a table and tilt the table, it survives. Try to push the
doesn't roll off.
away.
Okay. I think there's a demonstration for the
So an object that's
chicken
the
egg.
shape of these eggs affects the way they roll. If you place a hen egg on a table and then tilt the table,
That.
the egg will roll.
It's gone.
If you put a guillemot egg on a table and tilt the table, it survives. Try to push the guillemot egg away.
So is this a this is definitely a structural adaptation. Okay, structural adaptation. That means the egg, the shape of the egg allows it to survive. It doesn't die. Right. So there's actually another structural adaptation about this egg. Can you tell me what is it? There's another structural adaptation about this particular egg. Apart from the pointy thing, yeah. What's the difference between the chicken one and the this one, eh? Okay. Why so many lines? Why so many patterns?
So it can camouflage and the rock.
No, it's not camouflage.
So it.
Not for camouflage.
Oh, so the parents can
Can
tell the difference.
Yeah. So the parents can identify which egg, and then they do not accidentally hatch their neighbor's eggs. Right? So why? Why do they need to be so colorful? Because can you imagine this? This is their habitat, you know. This is their home.
Oh.
This is their home. So if you imagine they fly back and then try to search for their egg, it's going to be very difficult. So they can recognize the pattern, whatever pattern, right? The type of egg pattern that they have hatched, so they can find their own. Right? Next one. Okay, I'm not going to show this. It's the same. Okay, next one about adaptation is here. Yeah, this one. Okay, so some eggs use camouflage, right? So can you find the eggs in this picture?
No.
Which one? In the middle, okay? These two are eggs, so they are camouflage to the surrounding.
Why the predator never see them step on it?
Too bad, this is really too bad. Okay, but at least you prevent the predator from eating the egg. Right? Another one, you see here? Can you see where are the eggs? Which one is the egg?
4 of them in the middle.
Huh? 4 of them in the
The
middle?
one down there.
Where?
There's only one.
There? Yeah. Just in the middle. In the middle there?
Oh.
4 of them. In the middle. So you see, you are not lucky you're not the predator, right? So you cannot tell.
You just step on them.
But you don't know which one to step, right? You
Step
can't,
everything else.
you can't really tell. So this is also structural adaptation. Okay, another structural adaptation is this one. Okay. What? Yeah. Okay, so what's so special about this bird? Huh? So this one has to go in, it's going in to catch the fish. Okay, so what is the structural adaptation that this bird has to enable it to go and catch the fish?
Streamline.
Eh, sorry?
Streamline body shape.
Streamline body shape, what else? Hmm? Long, big, okay, and the big, do you think it's like very big, like a parrot? No, alright, so it is very sharp, right? So it can go in, it can cut through the water, go in and catch the fish. In fact, I actually want to see the video. Let me see whether I can see the video. So they can see the video. Okay, so the fish inside the water. See, they have to dive in, right? So if they don't have a streamlined body shape, or the beak is not streamlined, right? They will not be able to do that, right? They literally dive in to get the fish. Okay. Okay. Right, so let's continue. Okay, so that's the adaptation, right? So next one is about germination. So this germination. For germination, what do they need? What do plants need for germination?
Air, water, and warmth.
Air, water, warmth, right? So which part comes out first? The roots. Okay, so you can see here, the roots come. Why must it be the roots that come out first? Why can't the shoot come out first?
Can get the water first.
Yeah. Cannot? Can absorb water, right? For photosynthesis. Okay, so this is the process of germination. Right, you can see the roots come out first. Another reason is for stability. So can you imagine the shoot come out first, the big leaf come out first, what happens? It will topple. You know, if it does not have roots, the shoot come out first, the whole thing will topple. So the roots will come out first. Okay? Roots come out first. Followed by the shoot. Right, so where does it get its energy from? Huh?
Oh, you're talking about the seed.
Yeah, at this point of time. No photosynthesis, right? So the food come from where? Seed leaf, right? Yeah, see? And then after that, the coating will drop off. Right? And then what happens to the size of the seed leaf? As it's getting its energy, right? It will get smaller and smaller until the leaf comes out and is able to perform photosynthesis to get its own food. Right? Okay, germination. Fast forward, right? So the leaves haven't come out yet. Let's jump. Right, that's where the leaves start to come out. And then it can photosynthesize. I don't know. Depends on many factors involved, right? That's where the leaf, you see the leaf come out. So the roots must come out first. Leaf is after that. Okay, and then it'll start to grow. You can see all the seed leaves has literally disappeared already, right? Seed coat all gone. Okay? Right? See the leaf? Okay. Next. Okay, next is the respiratory system. Now the entire respiratory system starts from the nose, okay, goes down to the windpipe, what is the windpipe, and then after that to the lungs. So what is the purpose of the respiratory system?
For gaseous exchange.
Gaseous exchange. Okay, what exchange with what? What type of gas?
Taking oxygen and carbon dioxide.
Yeah, do you know the percentage? What's the percentage of the composition, right? How much carbon dioxide? Okay, in air, let's say air outside, right? How much oxygen is there outside? No.
24.
Oxygen.
21% of
21% oxygen
oxygen.
in air. This air. Okay.
78%
78%
nitrogen.
nitrogen.
And 0.03% of carbon
Yeah,
dioxide.
0.03 carbon dioxide. How about the one breathing out? The one that you breathe out? How much oxygen? Is there any oxygen in the air that you breathe out? Is there any oxygen in the air that you breathe out? Yes, have, right? If not, how to do mouth-to-mouth resuscitation? You know what's mouth-to-mouth resuscitation? If there's no oxygen, right? You know when a person collapse, right? And then you need to, if someone needs to perform mouth-to-mouth resuscitation, if there's no oxygen coming out, okay, the person will die, you know. You keep blowing carbon dioxide inside, the person will just die on the spot. Okay, right? So what's the percentage of oxygen that exits our mouth? Any idea? Or nose?
99%.
No lah. Less than 21%, okay? It is 16%.
Nitrogen the same.
Nitrogen is the same. Okay? And then carbon dioxide will increase to 4%. So the air that exhale air has got 4% carbon dioxide. Okay, nitrogen. How come nitrogen is the same? Because the body does not use. It takes in, but it doesn't use. So it just comes out. Right? So only oxygen and carbon dioxide is being exchanged. Okay? So now throughout this whole nasal, the nose, as well as the windpipe, there's actually a lot of tiny little hairs, especially in the nose. Okay? What's the purpose of those hair in the nose? Trap dust, okay? Prevent dust from going in. What's the purpose of mucus along the windpipe and the lungs, the walls?
Smaller particles.
The end, no. Not cool the end.
Trap smaller particles of dust.
Yeah, trap smaller particles of dust. Okay. Then where does all this mucus go?
They were dug out by shot.
No, dug out the trunk. The mucus. What happens to all this mucus? Anyone? Any
Go to
idea?
the nose. Then
Huh?
become the boogers.
Yeah, it's actually being swallowed, right? All mucus that is in your windpipe will come out. Okay, come up, and then you'll be swallowed.
No.
Okay, you may not know it, right? It's done unconsciously, one. Just like breathing, right? When you're breathing, do you need to go and think that I'm breathing, breathe in, breathe out, breathe in? No, you don't have to, right? So the mucus also the same. It will just automatically go out and then you just swallow it. Okay, but if you pay attention to it, sometimes you will realize that when you are swallowing saliva, you're also swallowing a bit of the mucus that comes out from the windpipe. Okay?
Can we don't swallow saliva?
Cannot.
Why?
Not possible. Not possible. Unless you have to go and keep spitting it out, no? Right? Are you going to keep spitting it out? Okay, so here I see nose.
You what the heck?
Nose. Picture of a nose, right? What's the purpose of the hair? Okay, trap all the dirt. Okay. Also, tiny little insects, right, may fly in accidentally, so it traps, prevents them from flying in. Right?
It's disgusting.
Yeah, quite disgusting. Okay, next is dispersal. So the last week we had this dispersal by explosive action. Right? What are the characteristics of plants that?
Hot and dry.
Yeah, hot and dry. So you can see over here. Here's an example.
Tree or plant. I'm not sure of the exact species, but it's got very interesting way of spreading its seeds. the same quantity, same open. It's agricultural.
Okay, this is explosive action, right? Okay, it must be very dry. If it's not dry, it cannot split. You cannot split and the seed is dispersed this way.
Wow, so fast.
Okay, still explosive action. Let's just show another one. So it has to be dry, next one. Here's another example.
Our seeds are crammed into a special pod. As the pod dries out, the pressure is intense.
Okay, explosive action. Just fly away after that.
Eventually, something's got to give.
Like spitting out.
Yeah.
Touching dots are even more on how they respond. The sun's contact triggers a chain reaction. Seeds light up the sky like a fireworks display.
Like a fireworks display. Explosive action. Right, and then one will trigger the rest. Okay? See if there are any more.
Another dramatic display comes from this unassuming
Right. So later there's also another one on this. Hey, hello. Okay, here's an example of the, they always do the experiment where they cut out the outer layer, right? They cut out the outer layer and then what happens to the entire plant? The top will swell, right? So this is like a live experiment. So you see they cut out this part. They cut out the bark at this part. Then the top will swell. Okay, you can see the top swell. Now why? Why does the top become swollen when you cut out the
The
fluid?
food from the plants cannot like travel to the roots.
Yeah.
So it's just stuck.
Correct, right? So the food from the top of the plant cannot travel to the rest of the part of the plant which is below. So it gets stuck at this part. Okay, so the whole thing will swell. Let me just go to the. Okay, here's another example, right? So you see they cut this, then the top will swell. Okay, it swells, it becomes bigger. Right, because the food gets stuck at the top. Right, next. Okay, next is about this. This one. Now, if this is a pond, and you have all these floating plants that covers the entire surface of the pond, what's going to happen to the plants that is submerged?
Die.
Why?
No sunlight.
Not enough sunlight. Okay, so they cannot photosynthesize. Okay, cannot make food, and then they'll just die because of you see all the leaves, right? They cover the sunlight, prevent the light from going down. Okay, another type of plant that does this is the duckweed. Now, what's the duckweed? Duckweed, this one. Okay, so this is a duck. This is a duck. These plants are called duckweed. These tiny little plants, they can actually grow very fast. So if you allow them to grow right in the pond, they will multiply very quickly, and very soon the whole surface will be covered with all these duckweeds. And then what do you need to do if you want to remove the duckweed?
Let's take it out.
Yeah, you can just dig it out. What else can you do?
Cut.
Cut. Caught what?
Put fish.
Put ducks out there. Duck weeds what? Right. That's
Oh.
because ducks like to eat ducks like to eat all these tiny little duck weeds. Okay, so that's why they're called duck weeds. Okay? Easy.
So it's like a weed to duck.
It's not a weed to the duck. Weed in the is a weed. Okay, what's the meaning of weed? What's the meaning of weed? WEED. In a garden, right? The weed is the plant that just grows rampantly without you having to go and interfere. So what do? You have to remove all the weeds, right? If you don't remove the weed, what happens? Yeah, your other plants will die because they take away. Yeah, because they take away the nutrients. They take away the nutrients. So the reason why people give these plants this name called duckweed is because it acts like a weed, right? It actually removes the nutrients from not just the water but below. All the plants and all the living organisms below, right? Don't have enough sunlight, and then they don't have enough food as well. Okay? And why is it called duckweed? It's because duck loves to eat them. So called duckweed, right?
Smoke weed.
Huh? Smoke weed? Who says smoke weed? Smoke weed. Okay, so these are duckweeds. And this one. Okay.
What's that?
What?
Above
Where?
that on the right.
Right? Nose.
Oh my god.
What the hell?
This is the nose. Okay, next is this one. Look at this. Oh, I cannot see it. Oh my.
It's safe to use.
Okay, if you have a
This is NASA's space power.
bowling ball and a feather, okay, and then you drop two together, right, which one will touch the ground first?
They take away the oxygen.
The bowling ball will smash the floor first.
The bowling ball will smash the floor first, right? So, but what happens if you take away air? You take away air, then you drop both at the same time.
Feather come up.
Then you die first.
Which one will touch the ground first?
Feather.
Huh? Blue?
No, you both.
I will touch the ground. No, why will I touch the ground? Okay, so they actually do the experiment. Okay.
Still brothers.
Yeah. Let me see.
Not only will you make a hole on the ground, the
You also
bowling ball
die.
will crack.
Yeah, right. So they drop the feather and a
Why the bowling ball so small?
because they said far away.
No, the feather's bigger than it.
They got a very big feather, so you can see, right? This is without removing the air. Okay, they never remove air. Next, they remove the air.
Then how do they remove the air?
They have
They
a
make the
pump.
person die.
There's
So
a
they
pump.
might not smash the floor.
Put cardboard there.
Why the person have a British accent and then there's an American flag in the background?
Maybe the British who went to America to do the experiment. Can or not?
And this one is Donald Trump's house. And the White House.
No, this is NASA, right? They went to NASA because only NASA have got this
NASA
type.
is
It's America.
Donald
Wow. Right, so now you see they remove the air. Okay, they close the space.
Then the guy will die inside.
Obviously the guy don't stay inside there, right? You
You
ask
don't
the guy,
enter
let the
with
guy
that.
go
You
out.
go enter.
Takes 3 hours to add the 18,000.
Okay, so they close the whole thing. Right, they call Donald Trump. Hello. Take out the air, can or not?
Drop Donald Trump.
And Donald Trump fought. And on the air.
This is so wow, so troublesome, you know, just to take out air.
Just for YouTube. Just for BBC.
BBC. Okay, and here they go, take out the air. When they take out air, it means there's nothing in the
So
atmosphere.
basically space.
Yeah, it's like space. Okay, but there's still gravity. It's just nothing. So they let go.
It's like just slow
It's like
motion.
slow-mo.
So which one drop first?
Both.
Feathers.
Both at the same time.
Because feathers are longer.
Okay, both will touch the ground at the same time. See, so happy. Yay.
Yeah, white hair.
Right? So both will touch at the same time. So the question is why? How come when you remove air, both will drop, you touch the ground at the same time?
No air resistance.
No air resistance. Okay, so the feather takes so long is because there's air resistance. It's like floating down. The friction between the surface of the feather and air causes it to drop slowly.
The feathers really good.
Yeah. Wonder where you get the feather from.
But now it looks like the feather dropped.
No, it's longer. It's just longer. So it touch.
You're making so dramatic.
Yeah.
Yeah.
If you do this in real life now, just go for it. Do millionaire and just
Okay. Right, so you need to understand this. When there's no air resistance, the feather and the ball will actually hit the ground at the same time. Okay, next is this is about elastic string force. So how to make let's say you have a little stone over here. How to make it go further?
throw it.
Throw away.
Put it back
No, what do you need to do? What do you need to do?
on.
Pull it further back. Okay, why? How come when you pull it further back, the bullet will go further?
More elastic potential.
Yeah, elastic potential energy. Convert to what? Convert to?
More kinetic energy.
Yeah, convert to kinetic energy. So you'll go further. Okay, easy. Next one. Oops, where did you go?
It vanished. Everything's vanishing. Not the back.
Okay, which one will dry first? A, B, C, or D?
D.
Why?
More surface area.
More exposed surface area. How come? How come more exposed surface area will dry first?
More exposed surface.
Heat the fastest, no?
No, of course, more water vapor can escape.
Correct. More water vapor can escape. Okay, so this diagram shows. Oh man. Okay, it's actually over here. This one.
Christian Brothers recommended.
Okay, so when you have a bigger surface area, this is a bigger surface area. This is a smaller surface area. More of the water vapor can escape. More can escape at the same time. Okay, as compared to a smaller surface area.
It looks like Tetris. It's a little surface area.
Tetris is bricks. These are circular stuff.
Yes, it is easy Tetris.
Okay, do you understand? Do you
It
understand?
looks like it's raining blood.
Okay, can Next. What is
The ball
the ball one? Okay, let me see. Okay, let me see this first. Oh no, it's not playing. Yeah.
Also, what does that thing? YouTube.
Let's go to YouTube. Surface type on friction.
Stop.
Different types of surface on
This
friction.
experiment try to investigate the effect of surface, the type of surface on friction. So we are going to test on a few material. One is on a cardboard material, paper. Two, plastic.
Singaporean.
There's a layer of transparent
Some
plastic
teacher in some school.
Three,
You know where?
sandpaper. And
No.
four, leather.
Funlearners.com.
Fun learners, they sell things.
Begin with,
That means they
plastic
sell
material.
gadgets
So at the
to
other end
schools.
of the string, there's a pen. And inside the box, you place the 50-gram mass. Okay. Let's begin with adding one
Fire.
Take note that the pen should be supported below the pen so that there's no impact on the pen. 2, 3, more. Okay.
So plastic
Now
only
we need to do
needs
this kind
3.
of experiment 2 times so that we can have a more certain answer.
So he do 2 times. Why?
1, 2,
Sandpaper,
Now
right? Change the surface.
surface to sandpaper. The weight 50 gram remains the same. Let the weighing begin. 1, 2, 3, 4, 5, 6, 7, 8, 9,
Imagine if it's 1,000. Skip.
10.
Oh, it moves a little bit. Oh, okay, it's gone.
Has already moved, so the number is 10.
Change to cardboard.
This one.
What's the red thing?
Huh? No, it's just different surface.
1, 2, 3, 4.
And diamond.
Okay. Simple. Right?
Last material is
Okay.
leather.
Leather.
Again, we have a 50 gram mass inside.
Okay, so leather, how many do you think it needs?
20.
20.
Between 1 and 100.
Oh, okay. Reminds me of a game, right?
Oh.
Anymore? Okay, is it more than sandpaper or less than sandpaper?
Less.
More, less. Who say less? One person say less. Two person say less. Anymore?
Hey, the spark time.
The rest all say more. Okay, let's see.
I don't say
You
anything.
didn't say anything.
Measure.
She got 85.5.
Who?
Ryan.
2,
This is she got it.
3, 4, 5, 6, 7, 8, 9.
Oh. Is it the same?
Less.
3, 10, so it's less. Right? So what can you conclude about this experiment? Friction, okay? So it's about friction.
So you can conclude the way to watch.
You what? Right, it's about friction. And the last one is this one. Okay, the bouncing ball. Oops. Okay, wait ah. The bouncing ball. Okay, it's a bit weak. It's talking. Okay, one more time. Okay, what do you want to see here? We want to see that the ball, right, when you let go and then it bounces, it doesn't go higher. Okay, it always goes like half.
Oh, what if actually goes higher?
It doesn't go higher. It goes half. Okay, so the question, of course, is why? Why does that happen? Okay, why? Okay, so you see the height, it goes lower and lower. Okay, why? How come the ball will not bounce higher? How come? How come it will never go higher than the previous height? You let go, right? You bounce. It will never go higher than the previous.
Because it gives the energy to the floor.
Give the energy to the floor. Like, hey, I mean, give you some energy. I give you some energy. No. What the-
The gravitational potential energy is converted
converted to
from kinetic energy, heat energy,
kinetic
sound
heat,
energy.
sound energy. Okay. So every time it bounces, every time it hits the floor, the energy is being some of the energy is being converted. Some is being converted to another form, such as sound, heat,
But then the
energy.
total amount of energy is the same.
The total amount will still be the same. Okay, there's no The energy is neither destroyed or created,
So
right?
break.
Yeah, what? They're always being converted from one form to another. Okay, can. Okay, so right, so we go for a short break. After that, we do the paper. Okay, can?
Can you start with the paper now?
Yeah, yeah. Okay, for those who are everyone is here. So let's start first. Okay, here. Don't waste time. Okay, come. If you need to go to the toilet, please go ahead. If not, you can start. Paper now.
Oh, we've done it before, right?
Yes, of course. All repeated.
Shit, why I never bring my
Eh,
phone? I never, it's like